So here we have merged ER underscore and updated it in the vocabulary. And when continuing with this, the next most frequent two adjacent symbols that we could find here is NE, because here it is appearing 6 times and here it is appearing 2 times. So that means 8 times we are getting these two symbols frequently occurring adjacent to each other. So we merged these two symbols together, and we also included that in the vocabulary, and then we also replaced that in the given corpus also. So if we could see here, what are all the changes we have done, everything is updated in the corpus. So like this we continue to do with the with that given text, and we can find then NE and W together, NE and W together for 8 times. So we combine these two, because already NE becomes a single symbol now, because already we have merged. So now NE and W we can merge it, and that is added to the vocabulary. And then we have L and O. These two are adjacent and appearing for 7 times. So that we first merge, and we add it as LO. Then when you get LO and W together again, you could see, so now this would be replaced with LO, and so LO and W together again we'll be getting 7 times. So again that is merged and we update in the vocabulary. Similarly, new and ER underscore that will be getting for so new already we have combined, so that will be available for 6 times. So that becomes again a new word, and then low and underscore. So like this we as long as we will be able to merge, we can do that and include all those new merged symbols into our current vocabulary. So now what we have seen is a token learner algorithm, and the second part is BPE token segmenter algorithm. So what the token segmenter algorithm would do is, on the test data, it runs each of these merge that it has learned from the training data greedily in the order what we learned them. And so here in the test data, the number of times it occurs frequently or what, it doesn't play any role. So what we have learned from the training data in the order in which it is merged, because here as we have seen, first initially we have ordered ER together, then ER underscore, then we have gone for NE. So we have gone into a particular order. So now this merge order, what we have done in the training data, that is going to be applied to the test set. So in the test data set, if you are getting a word new year, NEWER underscore, then what will happen? It will first merge this, and together it will merge this, and then NE it will merge, NEW it will merge, and combinedly it will merge this and find out this particular word as new year underscore, and that will be tokenized as a full word. But if we give a word lower underscore in the test set, LOWER underscore in the test set, what happens is, in our vocabulary there is no word called lower. Okay, because in our given list of corpus in the training data, we don't have any word lower. So there is what happens is, it will first merge this ER together, then ER underscore together, and then it will add LO together, then LOW together, and low. So low and ER together as two different tokens it will identify. So it means that only based on the training data set, what are all the things it has merged and added to the vocabulary, that alone could be identified as a token in its test data set corpus. So there are few properties of this byte pair encoding algorithm about these tokens. It usually include the frequent words and the frequent subwords. So subwords meaning this the suffix part of your words like er, es, est. So this particular part we again call it as morphemes, and this is the smallest meaning bearing unit of a language. So if we have a, particular word like unlikeliest, so what are the morphemes that we have is un, then est, and then likely. So these are all three different morphemes which could give some meaning to that. It holds a meaning. And we'll see about certain issues in this word normalization. Um, Most of the times when we write, we don't use a standard format. For example, if you want to mention the country USA, sometimes we used to have a dot in between each character and sometimes we don't. And these are all some expressions we used to give, and sometimes we use hyphen in between and not. And sometimes we write with the different like the uppercase or lowercase. So when we use this as uppercase, it may be a name of a person maybe, but when it is written as all lowercase, it is past tense of feed. So, and we have several be verbs, am, is, be, are. So these are all different, present in different formats. And to have all these kind of tokens in a standard format is very important. The second one is case folding. In IRS information retrieval. So in applications like information retrieval, it is better we can have all the letters to reducing all the letters to lowercase so that but there are times where we need to maintain the case of the word um, because for example General Motors. So if you are going to use small case letters for everything, it won't give the right meaning because General Motors is a name of the company. So if you are going to reduce everything to small letters, it is like some other word, general and motors. So, but when we write any name, you will be using it with the uppercase. So this is necessary to maintain at some point some of the uppercase letters. And like similarly fed versus fed is can be considered as a name and fed is another word. Sale versus sale, similarly sale may be a name of a company or something, and this sale has different meaning because this sale may be some abbreviation may be. So for doing the sentiment analysis, this and for information extraction and so on, this case of each word, it is important and it is helpful also. For example, in the same way, USA is mentioned as USA. Sometimes it is even mentioned as US, but still when we read we would be able to understand. But for computers to do this processing, it is better to be present in the uppercase because this US is different and this is different. And then we have another technique called as lemmatization. So this lemmatization means it represents all words as their lemma. That means each word that we are using has a head word form. In the dictionary, there is a root word for that. For example, we may be using a word eating, but the root word is eat. So from that, we are adding ing and making it as eating. So in lemmatization process, it represents all the words as their lemma. That is the base word or the root word. So here we can see that this am, or, is, these are all be verbs. We used to call it as be verbs. And so all these has the root word as be. And car, cars, apostrophe cars. Okay, so all these are all variations of this word car. This is plural of the word car. This is to represent that particular car, and that particular cars. So okay, so but the root word is car. So this is some example in Spanish. So what happens is in lamentation is that all these words would take their actual root word. Okay, so yes is be verb. Reading, the actual root word is read. And detective, stories. Actually, its root word is story. So when we do lamentation, the words in the sentence would be changed to the root words that is actually present in the dictionary. So how this lemmatization can be done is it can be done by morphological parsing. So what is this morphological parsing is that so in the previous slides we have seen the smallest meaningful unit, we call it as the morpheme. And by adding up all these some of these meaningful units, we make up the words. So in that we have two things are available. One is stems and another one is affixes. So stems, it is the main or the core meaning bearing units, and affixes, uh, the parts that adhere to stems, like how we see if cat is there, cats. So this yes is a affix that is added to the stem with some grammatical function, or um, easily. So the root word is easy, but it is ILY is added with some grammatical function. It is added, and it gives meaning to that entire word. So some stems and affixes are present in this morphemes. So when we apply a morphological parser over the words, what happens? So if you parse the word cats, then it would be divided into two morphemes. One is cat and another one is yes, because it is a affix that is added to this word. And fox, it will be as a single morpheme. And there is some Spanish example given, so we can check that. And another form of text processing is stemming. So in stemming, unlike lemmatization, this will reduce the terms to stems, chopping of the affixes very crudely. Okay, so as the affixes are chopped off crudely, sometimes it don't give proper meaning to that word. So here an example is given. This was not the map we found in Billy Bones' chest, but an accurate copy, complete in all things, names and heights and soundings, with a single exception of the red crosses and the written notes. What happens after stemming, you can see. So as we have seen in cats, this yes is considered as a affix, and so it is divided into two morphemes, one is cat and another is yes. So every time this yes comes, this is considered as an affix, and you can see here the word this is in this word this yes is chopped off crudely. The affix that the affix yes is chopped off crudely, and the word becomes thi. And similarly, was yes is chopped off and it becomes wa, not the map we found in Billy Bones. So here, because of this apostrophe, so here this yes is chopped off and apostrophe is removed, and it becomes two different tokens. Chest, but an accurate. Similarly, this 8 is also considered as an affix, because we several times we use that. If the base word is affection, then we can use a te to make it as affectionate. So like the so now this 8 is considered as a affix. So what happened, even in this word like accurate, this 8 is removed, or it is chopped off crudely, and it becomes an word accur, which doesn't have any meaning. Similarly, copy, y is removed and it is made as copi. Then complete, again e is also considered as a suffix and prefix and suffix, and it is removed in all things. So here s is chopped off, names s is chopped off. Okay, so like this, the stemming, it reduces the terms to stems, chopping of the affixes crudely. So we have a algorithm called the Porter-Stemmer algorithm. Based on the series of rewrite rules, it runs in series. Um, so it is a cascade. Also, as it runs in series, the output of each pass will be given to the next pass. Um, Here we can see that if anything comes as, for example, ATIONAL, relational. So for such words, automatically it is changing that to ATE. If we are getting ATIONAL, then it is changing to ATE. If it is ING, it is completely chopped off, nothing is replaced. If the stem contains vowel. And SS, yes. So ES is completely chopped off, and only SS is there. And in certain languages, the morphology is very complex, and we need to deal with it. If you look at this particular Turkish word, it is a very long word, and um, so we have seen in Chinese language there is no space between the uh, words. So similarly here also we have a very long word which doesn't have any space, but the meaning would be something different for each of these part of the word. So based on that, the morpheme has to be identified carefully, and the stemming has to be done properly. And finally, the sentence segmentation. So when we have, for example, a paragraph, okay, we have some 10 lines in that, and 10 sentences we have. So usually after each sentence we will have a full stop or a period. And so whether this period can be always considered as the sentence segmenter. So now when period comes, okay, this is this is sentence 1, and then this is sentence 2. So the period comes, so this is now sentence 3. Okay, can we do this always? But we need to check for other options also, because uh, sometimes this dot could be used somewhere else also. Some this apostrophe and question mark are mostly unambiguous, because only when a question is asked question mark will be used, and for exclamatory sentences this symbol will be used. But this dot or the period, it is not always used to complete the or finish the sentence. For example, the things like your Mr. or Doctor, and then some of the company names, Private Limited, LTD, then incorporation. So, or we have some numbers, okay, with percentage. So, all these things are also using the dot or the period. So now, can we use only dot as the if we use only dot as the sentence segmenter, what happens? This will be a single sentence, this will be another sentence, this will be a different sentence. Okay, so so if you have Dr. Raja, then what happens? Doctor will be one sentence and another Raja will be in another sentence. But that is not the case actually. So we have to use the rules or some machine learning algorithm to classify a period as either it is part of the word or it is the sentence boundary. So first we need to identify whether this particular dot is part of that sentence itself. Okay, if it is part of that sentence itself, or it is a sentence boundary. So here in this case, this dot is different from this dot. So that we need to identify first. For this, an abbreviation dictionary can be used. So whichever abbreviations are used like this, then automatically we can say that this is not the end of the sentence. Um, so usually this sentence segmentation will be done based on the by the rules based on this tokenization. So what we have seen so far is the basic text processing. We have seen there are or the text normalization we have seen. So for that we have three things we have studied. The first one is the tokenizing, and then normalizing the word formats, and finally segmenting the sentences.